Hi all, welcome to Mentor Minds. Today we are going to learn the chapter Exploring Forces of Class 8. Okay, so this is a very important chapter and also very interesting chapter too. So let's get started. We could see in this image two girls riding a bicycle. So we will begin from there itself. Okay, that is when the girls were riding against the wind, they had to push harder their pedals to move faster. So we know if we are riding a bicycle to a hilltop, we need to exert more force. That is, a more force or more energy is needed to ride the bicycle. But that is not the case when we are riding a bicycle on a straight road. We need to exert force, of course, but the amount of force would be much lesser. And in the third case, if you are riding downhill, then the effect of force or the amount of force needed will be much lesser needed. Okay, this is because of many reasons. We will learn about that in this chapter. Okay, so let's get started. So here you can see three images. One is a boy trying to move this object. Okay, first image, the boy is actually pushing forward the box. Second one, the girl has tied a rope on that object and is actually lifting, that is pulling up. And third one is that boy is carrying, it is actually lifting up of the object. So three different types we can see in this image. So generally we can say a push or pull applied on an object is called a force in science. So basically the push or pull applied on the object is known as force. That is one thing you have to note. Next, we in our day-to-day activities we apply different kinds of forces for doing different activities. So if your friend is holding your moving bicycle from behind to stop it, it means he is trying to pull, that is decreasing the speed of the bicycle will happens there, or stopping the bicycle. And secondly, if we are hitting a moving ball with a bat, that means a push is being done, that is it will change the direction of the moving ball. And third one is pressing an inflated balloon, that is also actually a push given. It will also change in shape of the balloon. So these are the three images, that is sorry, first one is you can see pulling the drawer, and second one is stretching. This is actually also pulling of this elastic rubber band. Next is a fielder trying to catch of this ball. This is also, these are different kinds of forces being exerted in our daily activities. So here as an example in our text given, opening a drawer, stretching a rubber band, fielder stopping a ball, kicking a football, applying brakes on a moving bicycle, rolling a chapati, or turning the steering handle of an auto rickshaw. These all are example of applying force. Okay, we know, no need to learn this one. We already know the effect of applying forces, right? So here it is given, the force applied on an object may, what happens when a force is applied, we know, make an object move from rest. If the object is at rest state, means if you are applying a force, means it will comes to motion, or when if it is in motion and we are applying a force, means it will either decreases or increases the speed, or else it will make the object to comes to rest and change the speed of an object if it is moving. We already said that point. Change the direction of motion of an object. It can change. If you are applying a force on an object in a different direction, it will from the path of the object, then it will make that object goes in different direction and bring about a change in shape of an object, that we have already seen the above example, that is a stretching a elastic rubber band means what happens, its shape will change, or else pressing a balloon, it also causes changes in shape. Okay, then cause some or all of these effects. These all are the things that happens when force is applied on the particular object. So, so when an object is at rest means, what does it mean? It doesn't mean that no force is acting on it. It is because actually the force acting on that particular object is in balanced force. We already learned what is balanced force and unbalanced force, right? So a balanced force means equal force. Two equal forces are acting on that particular object. That is a 10 Newton force from one side and 10 Newton from second side. Then what happens when then the object won't move. Okay, since that forces are equal, there will be no change in motion of that object. But if it is an unequal force means one side 20 Newton force will be applied, second side 10 Newton will be applied. So in such cases the object will move towards the greater where the greater force is being applied. Okay, this is difference between balanced and unbalanced forces. So here we understand that when an object is at rest means the force acting on it is actually balanced force. Now we are going to learn, are forces an interaction between two or more objects. To learn that, we know when you are pushing a table, we experience a pain on our hands. Instantly when we remove our hands, then no such pain will be felt. Okay, so this is due to the fact that while we are exerting force on the table for pushing, the same some kind of force is being received by our hands from the table. So the table is actually exerting a force on our hands. Okay, that is during interaction both objects will be exerting pressure on each other. Okay, so actually the definition of force can be said that a force is a push or pull on an object resulting from the object's interaction with another object. The unit of force is Newton. Its symbol is capital letter N. This is very important. Now we are going to learn different types of forces, which is also very much needed in exam point of view. So here we are going to learn two types of forces. One is contact forces, second one is non-contact forces. So let's begin with contact forces. So whenever object comes in contact, direct physical contact between the body and the object, this contact can be direct, such as using our hands or another body parts, or indirect, such as using a stick or rope. So forces of this type which act only when there is physical contact between the objects are called contact forces. Whenever a physical contact occurs between two objects, that particular force acting on them is called contact forces. So we will learn about different types of contact forces. Example, okay, first one is muscular forces. So we know we do several activities using muscles, right? This muscles will actually structures and stretches. The stretching of muscle will causes while we are stretching or doing several physical activities like walking, running, lifting, pushing, jumping or stretching, the force is actually caused by the action of our muscles. Okay, the force caused due to the action of muscles is known as muscular force. Okay, so our muscles, human muscles, actually contract and elongate. So due to this contraction and elongation, muscular forces occurs. Okay, so different kinds of day-to-day activities are being done due to the muscular forces. Okay, so these are different kinds of this swimming, this running, crawling, etc., flying, etc. are shown here. These are use of muscular forces by living beings. Okay, next is we can see in this image this cart being bullock cart and this horse cart. These are use of muscular forces of animals to assist with human tasks. Okay, these are to use human needs. Okay, these are some examples. So this is a type of contact forces. So simply we can say muscular force is a type of contact force whenever there is a physical interaction between two objects. Okay, or whenever the muscles stretches and elongate, there will be muscular force acting on it. So we can say of day-to-day activities, several day-to-day activities like chewing food, push it through the alimentary canal during the process of digestion. These are all examples of uh, muscular forces acting. Okay, the expansion and contraction of our heart muscles allows the blood to circulate in our body. All these essential survival processes are being carried out due to muscular force only. Now we are going to learn the second type of contact force, that is friction. Okay, we know if we are rolling a ball through a flat surface, it will stop after certain some time. Okay, if that particular road is rough means that ball will uh, get stopped sooner than on a that of a smoother road. We know that. So, we could say no force is acting on the object with our naked eyes, but the speed of the ball will gradually reduces and will come to a stop after some time. So, this phenomenon is actually known as friction. Okay, we understand that this must be due to a force acting between the surface of the floor and the particular sliding object, that is here our ball. Okay, so we could see this ball and between the surface of this ball and the surface there is some kind of force is acting, because of which the ball comes to stop even without applying an external force. Okay, so also we understand that this force must be acting on the object in a direction opposite to the direction of motion. This is what it brings the object to a stop. So, okay, so we understand that friction as a force that comes into play when an object moves or tries to move over another surface. Okay, and we also realizes that this friction will be more in the case of a rougher surface. If the surface sliding surface is rough means more friction will be there. If the surface is smooth, suppose in the case of a wet floor, what happens that there will be reduced friction only. That opposing force will be reduced, so that we will easily, if we are walking through a wet floor means there are chances of us slipping and falling down, because the frictional force is very much less compared to a rougher surface. Okay, so we understand that this friction is a type of opposing force which acts on the surface uh, of the floor and our feet. Okay, like that we can say. This is an example of irregular surface. The friction between these two surfaces due to irregularities, there is actually friction. Okay, if the surface is irregular, there will be friction, the force much more than that of a smooth surfaces. Next, in that box, you can see, does the force or friction act only if the object are moving on a solid surfaces? What about objects moving through liquids and gases? Air, water and other liquids also exert force of friction on the objects moving around them. Okay, we know on a solid surface there will be of course friction. The question is here whether water and gaseous state we feel frictional force. Yes, of course we feel the friction. That's why these aeroplanes, ships, boats, high-speed trains are designed with specific shapes to reduce the force of friction due to air or water around them. Understand? Now we are going to learn non-contact forces. Earlier, contact force means some kind of physical contact has to be there between the two objects. But here, that objects need not to be in physical contact. Thus, these forces are called non-contact forces. So, first type of non-contact force is magnetic force. So, we know magnets attracts objects made of magnetic materials. When two magnets are brought close to each other, we all know that unlike poles attract each other and like poles. Like poles means north north or else south south. They will repel each other. So even though there is no physical contact, there is an attractive force. Okay, between them. Thus, is the property of a magnet. So that attraction and repulsion between the objects are also a form of push and pull, and this is a force. Here it can be understood with an example. Okay, with the help of a wooden stick and two ring magnets, and we insert first of all a ring magnet, then and in the middle portion we are inserting that stick, and after some time we are inserting the second magnetic ring. Okay, and we will observe a magnetic force between those rings, and if we reverse the poles of the magnet, what happens, that attraction won't be there, they will repel each other, because we know what happens, unlike poles attract, like poles repel. Clear? So the force exerted by a magnet on another magnet or a magnetic material is called magnetic force. Since the magnet exerts a force from a distance without being in contact, it is called non-contact force. Clear? And another type of non-contact force is electrostatic force. This can be learned with the help of this example. We are taking a plastic scale. Okay, here you can see a plastic scale is being taken. Then a piece of cloth, a polythene cloth, and small pieces of bits of paper. Okay, so if you are rubbing that scale onto that polythene cloth for some time, and later on we are putting the scale near these small bits of paper, we could see the bits of the paper bits will get attracted to the scale. Okay, when it is brought close to the paper pieces, it gets attracted. This is because of the static charges is formed. Okay, when two objects of certain materials are rubbed together, electric charges build on their surface, and these charges are called static charges as they do not move by themselves. Okay, here one object gets charged. Okay, a charged object attracts, that is exerts a force on uncharged object. Here the charged object is the scale and the uncharged objects are the paper. The paper gets attracted towards the charged object. And here there is another activity also showing the same thing. That is with the help of two inflated balloons and a woolen cloth. We are rubbing both balloons with this woolen cloth. Okay, both balloons with woolen cloth and release them. Okay, we are not touching the rubbed balloons with our fingers after that. And when the balloons move away from each other, we feel as if they are repelling. Okay, now secondly we are bringing the woolen cloth used for rubbing the balloons close to one of the rubbed balloons. Then we feel like that balloons are showing some kind of attraction. This is because we know the like poles repel. Like poles repel. Here in the first case, the repulsion between the two uh, balloons is because both balloons are having the same charges, so they get repelled. And in the second case, we are bringing the rubbed woolen cloth in between. So here the charges of the balloon and the woolen cloth is different. So due to the difference in charges, the unlike charges get attracted. That's why in the second case the balloon gets is shown as attracting towards each other. So we can say the force exerted by a charged body on another charged body or an uncharged body is called electrostatic force. Okay. And also the third kind of we are going to learn the third kind of non-contact force, that is we can see here an object being dropped and a fruit falling from a tree, a, a girl being jumped, she will of course come towards the ground, and the ball, and the third and last photo. Clearly we can see these objects are being thrown upwards and come to the ground. So what causes this? We understand that all the objects fall towards the earth. It means the earth attracts them. The force with which the earth attracts objects towards itself is called the gravitational force. Okay, so this gravitational force is also a kind of non-contact forces. All the objects in the earth's surface are being pulled towards the center of the earth. Okay. It is also a type of non-contact force. But the difference between the three non-contact forces, that is the gravitational force, then magnetic force and electrostatic force, is that the gravitational force is always attractive forces, unlike magnetic force or electrostatic forces. They will there we have seen that only like poles repel and unlike poles attract each other, but gravitational force is always a attractive force. Here we know the first in this image, firstly the boy is dropping the ball. We can see this when an object is being dropped down, it will comes vertically downwards a much faster rate. But in the second case, throwing an object vertically upwards means initially as this ball is being thrown up, it is against the gravitational force, so it will go slowly only. Then it reaches the peak point and stops there momentarily for a minute, for some time, and gradually it comes down. Okay, so it follows a vertical path downwards. Next is weight and its measurement. So what is the difference between mass and weight? We know mass means the amount of matter that is contained in an object. Its SI unit will be gram or kilogram. We already know. But the weight is the force with which the earth pulls an object towards itself. It's the weight. Its SI unit is Newton, capital N. Here you can see this with the help of a spring balance. A spring balance is a device shown like here. A hook will be there for attaching objects, and according to the weight of the object, the spring gets expanded. Okay, if the weight of the object is small, means the spring will get expanded at a lesser amount. If its weight is greater, it will extend like as in third image. Okay. This is spring balance, and we can see the maximum weight a spring balance can hold is 10 Newton. Its range is 0 to 10 Newton only. One small division in a spring balance is actually 1 Newton divided by 5 units, that is 0.2 Newton. Earlier we learned that mass of an object, we learned about mass and weight. Mass is the amount of matter contained in an object. It will remain the same even if we are in Earth or else in Moon or any other planet. The mass remains same. But what is the weight? Weight is actually the force which pulls the object towards the Earth. Okay, so that gravitational force will be different in different planets, right? So if a person weighing 1 kilogram, whose weight will be 10 Newton, but when he is in Moon, the planet Moon, means his weight would be 1.6 Newton. If it is in Mars means the weight would be 3.8 Newton. And if he is in Venus or Jupiter, the weight will varies. In the case of Jupiter, it will be 25.4 Newton. Our weight gets increased dramatically. Next, we are going to learn a very important topic, that is floating and sinking. We know if you are placing a plastic bottle on a water, on a bucket filled with water, we can see the object just floats. Here that gravitational force is not acting, right? If we know every object in the earth will actually sink. Okay, but why this bottle is not sinking? It is because in the case of liquid, there will be a upward force. Okay, the force applied by a liquid on an object in the upward direction is known as upthrust or buoyant force. This buoyant force will be acting opposite to the direction of gravitational force. If the object, if the particular object is of lesser density, what happens? The buoyant force or the upward force will be greater. That's why here the plastic bottle is floating. If the object's density is greater, it is having a greater density means the upward force or the buoyant force will be lesser, that so it gets sinked. Okay, sink to the bottom. This is the case with buoyant force and gravitational force. They are opposite to each other. It all depends upon the density of the object. And there is another important thing, that is Archimedes principle. The scientist Archimedes, he found out that the weight of liquid displaced by an object is smaller than the weight of the object. The object will sink the liquid. If the weight of the liquid displayed is equal to the weight of the object will float in the liquid. Same thing. Here they are shown a rock called pumice formed due to volcanic eruptions. It is having so much of pores which shows tiny bubbles of gas inside. So even though it is a rock, it will actually floats on it because it has so much of gas inside. So this is all about the chapter exploring forces. Thank you.